So now we're going to look at a little bit more complex problem, number 19, where we really have an equation that we need to solve and then graph the solutions for x. So again, we're looking for anything that makes this true, anything that we can take 2 times x plus this and get something greater than 9. So the first thing we can do, we can kind of guess our way through this again. If I just thought of x as 0, 2 times 0 is 0 plus 1 is 1. That's not greater than 9. So that doesn't look like that's going to be enough. So if I want to guess higher, let's just guess 5. So I'm actually going to go 2 times 5 plus 1 and ask the question, is that greater than 9? So 10 plus 1 is greater than 9. So that works. But that's might not necessarily be, so I know at least 5 works, but let's go less than that. Let's go 1 less and make it 4. 2 times 4 plus 1 greater than 9. Is that true? 4 times 2 is 8 plus 1 is not greater than 9, but it's equal to 9. So I could think of this as if x were 4, it wouldn't work, but anything even slightly greater than 4, like 4.1, see if I went 4.1 times 2 is 8.2 plus 1 is 9.2. See, that works. So anything bigger than 4 would make this true. And that's one way to do it, sort of to guess numbers to see if you can find something that will make this true. Whatever this is greater than 9. Or I can solve the problem algebraically and just actually look at what does if I solve 2x plus 1 is greater than 9. And I actually go ahead and just solve this equation for x. In other words, I want to find out what this is, get rid of everything else but this, the sign, and something over here. And so to do that, I'm going to kind of undo this. I'm going to work backwards. Since this is a plus 1, I'm going to subtract 1 from both sides and keep that inequality sign right there where it's at, because I can do the same thing to both sides as long as I'm always doing the same thing. So now I'm going to go 2x, and that goes away, is greater than 8. 9 minus 1 is 8. So if I have that, and then again to both sides, I'm going to divide by 2. Since there's a 2 there, that's 2 times x. I'm going to divide by 2, and that means that becomes 1 times x, or x is greater than 8 divided by 2, which is 4. Now that inequality, x is greater than 4, is what I graphed. Here's the open circle showing it doesn't include the 4, and x is everything over here. So any values over here, like 10 would work. 10 times 2 is 20 plus 1 is 21. That's greater than 9. 5 we already showed would work. 5 times 2 is 10 plus 1 is 11. So 11 is greater than 9. All of these values, everything to the right, continuing on, will always be greater than 9 as long as we start with at least a number that's greater than 4, not including the 4. And again, that's why the circle is open. So it's a much more complex problem. But again, you can either do it by sort of guessing your way through it or by solving it using algebra or algebraic way of kind of undoing the problem, undoing the addition by subtracting 1 from both sides, undoing the multiplication by dividing both sides by 2, and coming up with a simplified version of the expression, the equation x is greater than 4.